Hey everyone, thank you so much for coming. We are having our presentation today on flower classification. So without further ado, we are just going to jump right in. We'll start out, obviously, classification does come down to looking at the minutia of what the plants are and figuring out those genetic links, species categorization. So I read a book actually, and it was called, let me pull it up quick here. How Zoologists Organize Things, The Art of Classification by David Bainbridge. And it kind of talked about the history of classification and where the origins began. And it actually argued that it started in the Bible with Noah's Ark, species two by two. And then the book had different examples of how Noah's Ark was organized, and it had all the animals, and so that was actually very interesting to see that historical concept there, um, because that, is how we mark the beginning of time. Common era, of course, now for political correctness. But otherwise, um, that is kind of where it potentially started officially, at least that we have record of today. Otherwise, we do have Darwin's theory of evolution, which is definitely one that gets a lot of recognition in science and science history, where he went to the islands and he started observing the wildlife there and down in South America area, Central America, South America. And so he started observing and just taking notes on what he saw, and he started trying to link and understand everything and how it all worked together. So his theory of evolution. But it is kind of hard. It's hard to differentiate um, just how things are related. And I believe that the book that I just referenced by Bainbridge did say that it is hard even to differentiate between sexes of species, just because a lot of times, like for example, cardinals, you've got the brilliant red of the male, and then the females are kind of brown red, and so I think the book by Bainbridge referenced different bugs and how different and unique they were from, male to female. And it doesn't really end with that. There are so many likenesses and differences to look at and to observe and to figure out how to test genetically. And science is still changing and growing in this capacity. So of course, we are lucky today that we do have DNA testing and the potential to find codes and similarities in that regard for different species. But that's still, a developing strategy, and it's like collecting a database, let alone something that might even be close to comprehensive, would be nigh on impossible. Um, so that is saying something. It is difficult to figure out just what is where, when, how, and why. Um, I did a little research on flowers specifically, flower and plant species. So I just went straight to Google, typed in how many plant families are there, and it said there are more than 600 plant families. So, however, the exact number can vary slightly depending on the classification system used and ongoing research. So 600 different families. Um, let's see, they are split based on shared characteristics, flower structure, fruit, and seed. And then it has the list of the most common ones for the plants, flowers specifically. And we have the Astraceae, sunflower family, Rosaceae, and I apologize, I do not speak Latin. I don't have that skill. So I studied French. So I am just guessing on this, but Fabaceae, Lamiaceae, Orchidaceae, Brassicaceae, Liliaceae, Apiaceae, Iridaceae, Ericaceae. So, roses, sunflowers, legumes, mints, orchids, mustards, lilies, carrots, irises, and it just keeps going. So it is actually fairly impressive what we have in place for structures. They are very, very complex. Because to do the stratifications, the classifications, they do look at genetic similarities. So this is an example of just one type of flower, well, one type of family that I looked at. We could argue, and it is two very, very similarly shaped flowers that are actually both used and enjoyed by butterflies. So on the left here, we've got milkweed. You can see that it's got the one, two, three, four, five petals along the outside, and then it's got these little arms reaching into the center. And then we've also got the butterfly weed, this orange flower here, and it's got the same, the five with the little um, elements that are curling into the center, and the center also looks comparable. So that those are genetic similarities between plants that are both used by butterflies. So you might find these in butterfly gardens. These are actually both choke cherries, so there are a lot of similarities here, but there is a marked genetic difference, and that is the color of leaf. So you've got the purple back here, you can see in the background, and then we've got the green. So even if they are the same, you are going to find those genetic differences. Like obviously with the butterfly plants, we do have they are obviously very, very different plants. This is cream. They've got more points to the structure, and it's a little bit bigger. And this is more rounded, and it has a little more flavor in the back here. I don't know. That would be like the sable, but but this is this is a genetic difference. And so, in theory, we should be able to use that to figure out difference in genetics and just differences in where they came from. So, this is another example of a genetic difference. I believe this is a lesser trefoil, and it's got leaves that look comparable to what a clover might have. And so when I was earlier in the summer, when I first started working with this plant, I was presuming it was a clover, and clovers are legumes. They are from pardon me, I'm just going to go back a couple slides so I don't, the Fabaceae legume family. And they are meant to, it has been argued that they are nitrogen fixing. And so that was interesting just because nitrogen obviously gets stirred up and ends up as a potential gas, as a greenhouse gas. And so um, this was a potential area of study just to see what these plants do to capture that nitrogen that makes them different from other plants. So very, very interesting. But I mean, it looks like a clover, but if you look here, these seeds are not in a legume. They're not in like a bean pod. They're not in something specific. They are separate, and they are down kind of by the leaves. So despite the fact that it looks like a clover, or it looked like a clover, it is pretty tall for some clovers, but not that tall for other clovers. Um, so it was just a unique genetic difference there. Looking at the seeds, um, can also kind of show you differences in what where they came from. So this is just a couple of examples where you will have genetic differences of how the seeds are structured. This is that lesser trefoil again, what we just saw on the previous slide. And this is what the seed looks like when it's actually on the plant. The green here, the brilliant, vibrant green, and then this is actually the vibrant green that's been sitting around for a while. Or, oh, pardon me. No, I think these ones, that's the dried green seeds down here, are the ones that have been sitting around for maybe a week or two. These ones I think were naturally this color because these are not mature, so they are not quite ready to fall off of the plant itself. They do turn black after they have dried, so the black seeds are the ones that fall. Wood sorrel is completely different because it is in the legume. So these are the ones that are separate. These are the legumes. So you can see the pods down here. And actually, it was pretty cool to play with these just because I hadn't actually collected the wood sorrel seeds before. And these pods kind of pop open sometimes. And so you will just have seeds just like popping out everywhere. And it's actually very surprising, and they will just fly in all directions. I can't tell you how many I got like just in the face trying to collect these seeds, trying to take them off of the plants where they came from. But these seeds, and of course, these are also different maturity levels. So like the bright, brilliant green up here were still on the plant, and then the black were also still on the plant, but they were ready to fall off, or they fell off much easier. So these ones were arguably more mature and ready um, to fall and, you know, continue the species in that regard. These the wood sorrel. These also were kind of spanning. They're never all going to be mature at the same time. So like starting from left to the right and then going down the row from the top to the bottom, you can kind of see how they change with maturity over time. So the cream to the yellow to the light brown to the brown to the dark brown, and then it loses that protective coating, and then you just have the seed here, but they are totally, totally different. And so they, again, both seem clover-like in, you know, how they appear, but the wood sorrel, the seeding is completely different. So just something that is kind of interesting. Choke cherries, the green versus the purple leaves. Some might call them red leaves. I call them purple. But just looking at those seeds, obviously we had a huge difference with the lesser trefoil versus the wood sorrel. But the choke cherries, there was very, very, very little difference. I think it says here the green leaf seed is fractionally smaller than the other. And this is the two of them side by side. So if you, oh, pardon me. So if you look, there is very, very similar over here with the surface, and they both kind of have a ridge and the edges on the long ends. I don't know if that's a great way to define that, or but those are very, very similar, which makes sense because they're, you know, the berries seem comparable, and they are both choke cherries and similar leaf structure. So it's just the color of the leaves. So that's a good note to have. But looking up flower diagrams just to kind of see, um, you know, how they work. We found the seeds. Obviously, the wood sorrel and the lesser trefoil, the seeds were completely different. So just asking Google again, what are those? What parts constitute a flower? And the browser does show a lot of, the same style of flower, but that might not actually be representative. It's not comprehensive for all the types of flowers that there are. So just looking up flower diagram is not going to get you all of the information that you need for such a diverse classification system. So this is an example. These are all of the white flowers that I found just in my mother's yard. So these are all white. That is a genetic similarity. A lot of them have yellow centers. You can see the same in pollen. Have the yellow there. These ones are actually closed, but you can see at just, oh, there's one that's kind of open, just a little white on the outside, and then a little yellow on the inside. But they are all, they all have those similarities. They're, green stem, white petals, and then the yellow in the middle. But they are all obviously very, very different. Like this is an aster, an asteraceae. This is a clover, so it's a fabaceae. This is actually the chokecherry that we looked at. So, and this one is fluffy like dandelion. So they're all very, very different, but they're all white flowers. So I went to my browser again. How many white flowers exist? And it said it's impossible to know for sure how many there are, but it's estimated 400,000 different types of flowering plants that produce white blooms. And I had previously looked up, how many different types of daisies alone there were, and it said like I think it was 1,000 plus just of daisies alone. So lots and lots of varieties. I can't even imagine classifying all of them because this was literally just from my mother's yard. And how many were there? It was one, two, three, four, five, six, seven, eight, nine. Nine. And I think, yeah, that might be comprehensive. It might be comprehensive. Um, but here are some examples of white flowers. We had the daisy, but I'm not sure that we had any of these other ones that were suggested. Camellias, hydrangeas, daisies. We had magnolias, gardenias, tulips, snowdrops. So a lot, and none of the ones that were in my mother's yard are represented here, just daisies. So, kind of wild. And that doesn't even include all of the other colors. So these are um, also flowers, da-da, from my mother's yard. These are also literally all just from my mother's yard. Big shout out to her for letting me study her yard this past year, because it was actually very cool. I wasn't anticipating the amount of biodiversity that was there, so it was actually great, and they're still in the house that I grew up in, so I kind of took it for granted. But it was actually amazing. It was really cool to see just what all was there. So very cool. But these are all the different colors, of course, and they all have different structures. So this is a sedum. This is a sedum. Let's see. This is I don't know what category honeysuckle is, but it's definitely unique compared to like this. This is the lily, liliaceae, dandelion. I think probably would be categorized as an aster, asteraceae, rose, rosaceae. So all sorts of different styles here, let alone this guy in the corner. very, very unique. So this is that's her yard with all of the biodiversity, and this is my garden, with very few flowering plants except for the tomatoes, which still boggle me because I don't really see any noticeable stamens. I did study them. I put them under the microscope, and they've just got this tube, and inside I'm presuming that maybe that is the stamen. Otherwise, that is the otherwise that's the stigma. It's got the the piece that goes directly up. So but I was just trying to figure out, what am I missing here? I cannot find the stamen with the anthers or any sort of pollen. So I may have to look again, but my garden is a lot messier and a lot smaller. Well, actually, to be fair, this plant is now flowering. It's been a couple months since I took this picture and or maybe it was even just 1 month. I'll have to look at the dates specifically, but now this one is flowering and it's very cute. It started out as like white to pink and now they're mostly white blooms. So I've got white blooms after all, just like my mother. Very nice. But here are more diverse flower diagrams. So just to kind of go back, now that we have seen more of the biodiversity, aside from just that traditional one, which I think was a lily, Liliaceae. But now we've got the flower diagrams. These are the legumes, legume flowers, like our bird's foot trefoil, the clovers are going to have this structure here. Orchids, then we've got the asters and then the lilies. So you get a lot of diverse flower diagrams there. And this is not even comprehensive. Obviously, 600 different, what was it, families of flowers. But I did study the flowers that were in the yard, and so these are a few different types of the stamens that we saw. And it's actually amazing the differentiation here too, just because this one obviously has the usual structure of like what we saw in the diagram of just looking up flower diagrams. It's got the stamen surrounding this inner pistil, this inner stigma area, and then we've got the anthers here with the pollen, and then this one is actually um, it's got the stamen, but they're kind of as like a little gift here. They're wrapped around the ovary here, the ovum. And I will apologize. I have seen so many diagrams and I am doing self-study, so it's hard to know which vernacular is used by whom. So I apologize. I am kind of ad-libbing and working with what I have seen. Um, but this one, the stamen do kind of meet up here, and then they have the anthers there. And then these ones the pink are just kind of all over the place. They're all bent around. And so lots of biodiversity even there. As to the interesting classification process. And this one is uh, different placement of reproductive organs. This one again follows that traditional placement. Um, Apologies, I want to get this bottom bar gone, but I don't know if I will succeed. That's okay. That's okay. We'll leave it. But this one over here has the similar structure to what we saw with the stamen and anthers along the outside. And then this one actually has that center that's pretty thick. It's definitely not the same if we look over here, because it's got more hair-esque filaments and it's got more almost like gel-like fingers on the outsides, at the top here on the fringe. And this is definitely more smooth and more smooth. So, but this is the traditional stamen on the outside with the middle in the middle. And then this is an aster. So, it's got a lot of um, uh, flat pieces in the center. And then we've got these, I believe this was, in a diagram as the stigma. So this would be like this on other flowers. So it's just a unique structure. This is the edge, this is the petal. So if it's a daisy, this is the daisy. So this is the edge to the center of the daisy. And then we've got the petals there. So another thing that differentiates, then these are different types of that center column of the stigma. And so obviously this one has a huge ovary as well. So that's also a differentiating factor. But just again, here's the hairy with the gel-like fingers on the edges. Versus the one that is more smooth. This one, if you look here, it looks like it has kind of a swoop swirl on the in the middle. And I didn't get a great picture of it. So I have to look at that again, but I have seen that structure in a few others as well. So this one obviously has like four different, at least four plus um, kind of arms reaching out at the top of the ovary. So ovary ovum. So all different. And these are just four different types of flowers, and they were all in my mother's yard. So um, it's a very large task to try and categorize these flowers. It is complex, and research is consistently building and clarifying these familial bonds. It's amazing with the biodiversity that we have. We'll go back to this slide. We're wrapping up. So it is just amazing. All the differences in just a very small space, just completely wild. So, um, are there any questions? All right, then we will wrap it up. Um, Thank you for your time, and we'll see you next time.